Here we are again, folks. It's Redox Stoichiometry this time. So you folks in AP Chemistry, remember, you don't have to be here. You get to be here. You signed up for this. So let's get right to it. We're just going to do one example here to help you see that redox stoichiometry is a lot like acid-base stoichiometry and, quite frankly, every other stoichiometry problem you have ever looked at. Just balancing the equation is going to take us a little while longer. So in this question we have 50 milliliters of 0.1 molar potassium permanganate. Notice we have volume and we have molarity, so when we multiply those together we're going to get moles. All right, we're going to titrate to the endpoint with 20 milliliters of iron 2 sulfate. How do I know it's iron 2? Because there's only one iron with one sulfate. Sulfate's a -2, so this is iron 2. Let's balance the equation. And we're going to drop off our spectator ions right away. We're not even going to list potassium or sulfate. By now you should know those are always soluble with these materials, so we don't need to bother with them. Let's see. So we've got iron 2 and permanganate as our reactants. Now what do we have for products? Let's see, I believe I still have that worksheet open. Yep, sure enough. So we're in acidic solution. Permanganate is going to turn into the manganese ion. And then iron 2 is going to be down here. Metallus ions become metallic ions. All right, so that's what we're dealing with. Those are our products. We have the manganese ion and then the ferric ion. Alrighty. Now let's make sure everything except for oxygen is balanced, and manganese is good, iron is good. Now let's take care of that oxygen. We have 4 oxygens. Oops, so I need to add 4 waters. All right, so we have 4 waters. Yep, that's a 4. And 8 hydrogen ions will take care of that. Let's do electrons now. This one lost 1 electron, and this one was a plus. I don't remember, +5? Let's see, -1 is the overall charge, -8 from the oxygens, and then X, 7. So we went from 7 to 2, so that was 5 electrons that were gained to go from a 7 to a 2, because that went down. So gain of electrons is reduction. We had 5 electrons for every manganese, and now we're going to make these the same. Multiply this one by 5. I'm going to go ahead and add these all up all at once. So I get 8 hydrogen ions plus a permanganate ion plus 5 ferrous ions, and then 1 manganese ion, 5 ferric ions, and 4 waters. Okay, there's our balanced equation. And we needed to have a balanced equation so we can work out the mole ratio here. We're going to start with, we don't even know what the question is. Oh yeah, here it is. Concentration of the iron 2. So we already have moles of permanganate. We just have to do the math. So change milliliters to liters. We're starting with 50 milliliters of permanganate. Change it to moles. Volume times molarity gives you moles. Alright, so for every 1 liter of permanganate, we get 0.1 moles. And now we are going to use the mole ratio. And we want to change permanganate into irons. Iron 2s to be precise, not iron 3s. Alright, what's our mole ratio in our balanced equation? For every 1 of these, I use up 5 of these. So it's 1 to 5. And now we're not done yet because we want concentration. I have moles. Now I need to get moles per liter. So where are your liters of the iron 2? That was up here in the iron 2 sulfate. So put 20 milliliters on the bottom. Just make sure you change it to liters first. Now it's time to do the math. So we take 0.05 liters times 0.1 moles times 5 moles, and then divide by 0.02, and I get a concentration of 1.25 molar iron 2. We have now done a stoichiometry problem with a redox titration. Just like acid-base, just it's the balancing part that can be tricky. So once you know how to balance a redox reaction, you do everything else just like normal. That's it, guys. Good luck.